computer that has a Wi-Fi, it's a computer that has Bluetooth, it's a computer that has a display, it has a battery, it has a nice interface. It keeps your memories, it keeps your files, it keeps you connected to other people. The thing is that here in Portugal now we remember how it feels not to be connected to other people. So when the electricity goes down, internet goes down. And then the things that we have in our pocket, these phones, they become quite useless. I mean, you can have them for sure, but you can't really use them anymore. You can say you can use Wi-Fi, but it's very limited, right? So you can use it in your house maybe, but you can't really share it to others. And we looked for a long time for applications that we could use, because we live in a time that we don't just think about emergency situations, we also think about our own privacy and being able to share with our friends, with our family, with other people around us, our thoughts, our ideas, our things, without really being afraid how they are being seen by someone in the capital or elsewhere and what judgment they might have about us. In this type of platforms, in big part on top of Nostr, because quite honestly, it was a thing that was mostly suited for this. So Nostr is not needing to be connected to the internet. That's the best thing, since you already talked about the public and the private keys. And then we started this platform that you see in front of you as kind of a hybrid between the radio world and the digital world. So David was giving his experience about packet radio, how it was used in the first days. But it also seems that since the 80s and the 90s, it didn't really move that much, at least for the idea that people here in this room could be. So we put ourselves with the challenge. Well, I have to say that first we tried with LoRa and we learned about it and so on. But then eventually we went to Hamnet, we learned about APRS, and then we merged it with the things that we knew. So the type of digital world that we come from. And the result is really in front of you. So this is a web platform that anyone can access today. And it's showing you in live stream all the radio stations that people like David and many others are maintaining since decades. They are doing it on a volunteer basis. They work. But the thing about them is that they already come with a very nicely defined standard set of frequencies and services that we can talk to. And they continue working even if there is no internet, even if there is no electricity. Of course, many of them would go away, but many of them would still stay. And you ask, well, how useful is that? We were talking about Wi-Fi that you can connect in the house. We can talk about Bluetooth that can go over there to the bottom of the street. But these things, when I'm talking, for example, with one of these devices here, it can quickly reach 50, 70 kilometers. David will agree or disagree very quickly because he'll say, line of sight, good antennas. I'm learning my lesson. But in the end of the day, these things can go really far and they are really affordable. So they are not something that is high-tech. They are not really, you need to learn to handle it for sure, but then the frequencies and the range that these things have are really quite unparalleled. This is more or less a medium range device, maybe. The professionals are here, so they would complain. But there are cheaper ones. So there are some other models like this one that will cost 20 euros, for example, on AliExpress. And they are also perfectly valid to some point to send some data, talk to some other people, and simply work. So as you see, there are options for all prices and all ranges. And Geogram itself, as you see right now what it's doing, we are focusing on a radius, on this case of 100 kilometers, and we can see the communications going on here. So when we write something on that chat box, it gets sent to the radio stations on the ground and then received by the walkie-talkies there, and from the walkie-talkies back to the phones or to the laptops, to wherever they are connected. I'll get there in a moment how they are connected. But it works on both sides. If I'm on my walkie-talkie on my cell phone, I can also send a message from my cell phone to my walkie-talkie, which gets to the radio station and then goes to the internet, assuming there is an internet, because this platform is made for the internet. But there are more things that are being done. So, for example, if we are talking just about phone-to-phone communication, we are trying to make a way to make this thing not to be useless the next time they cut down the electricity. Meaning, you install Geogram here, and you can have the basic communication based on Bluetooth, BLE, so contacts people from one side to the other. They don't need pairing, so I don't need to pair to you, you don't need to pair to me. It's automatic. Why? Because you're giving permissions for that, and there is a set of things that it starts doing it when it's within the range that are quite useful. So for example, here we are in Embaixada, and we want to create, let's call it a server. or a node, let it be a Nostr node. And now you learn that you can do it also with a cell phone. So indeed, I'm going to put my phone over there, patch it against the wall, and then says, this is the Embaixada station that works with Bluetooth, has Geogram installed here. Anyone that has the same app installed, they know that they can come over here, or they are minimally informed about it. There is a database that is offline, can tell you where is the nearest one, and you can go there and start writing your message to someone. Over here, we try to be very complete. So David is helping us. We are going to have a radio station that is quite independent. We want to have it on batteries and on Starlink and on solar panels. It will continue working to an extent. And people can still come over here, send their text messages, and have more or less of a guarantee that it will still be dispatched somewhere else on the planet. Not with the quality of an Instagram, not with the quality of a YouTube for sure, but you can call your loved ones, you can call your friends, you can still do things with text to let them know that you're okay. But it doesn't do just that. So we went a bit beyond, and now what this thing is doing, it can talk directly to other people on the phone to phone, and they can exchange messages on their own. That's the most basic things. You can have a local chat around here, where we are all chatting on the building, how are things doing. But we can now do other things like sending private messages based on Nostr, for example. And we can do the last thing, which is geographical messages. And this is the most interesting part. I think I was mocking with you because I was telling you, oh, you can do it with antennas, you can do it with satellites, but then you can also do it with the shoes, which is you ask someone to carry the message for you digitally. So I send a message to you, and you become the carrier that takes the message to the next village or to the next city for other people to then be dumping it on the next Embaixada that is available in some other place. And this way, we can have the public part of the message, which is the geography of it. So where do I desire that my message goes? Based on the public key, based on the coordinates, and then hoping that there is some network that will bring the message to that destination. We don't really define how to get there. This is something that people can define on the ground. But we give the way for people to do it without papers and with privacy and for free. And since they can do that, they can also do many other things. So for example, they can set up warnings, they can set up news. So every time that I come over here, I can see what is going on in the Embaixada. Oh, and then I'm starting to see all the news coming, and I can read about what is going on. Think about it like the Nostr or the Twitter from the old age, but without the internet. But you just have to physically go there and start reading what is going on. This gives a second life to your phones if there is no electricity, and makes them useful. So you can, because they will continue to be used. You have your pictures there, you have your personal stuff, they still work, but you still want to share them, you know? You want, for example, we are all here. I hope next year we can have all Geogram installed. It's only going to be available for the phones on March, but I hope that we can all come to an event and start sharing the pictures we have on a global event here, and not having to share it in some server from Facebook or from Twitter or from someone else. But no, it will be saved on the server from Embaixada, which will be a very normal phone sticking over there on the window. And I hope they don't break the window to get the phone afterwards. But it should work. It doesn't just use phones. It can also use other things. This is a very tiny computer based on ESP32. It has an e-paper screen, it has a temperature sensor, it has a memory card, it has, what else can I remember from here? Wi-Fi, Bluetooth, lots of processing, and the battery, all for the crazy price of 25 euros. This thing is a full computer with e-paper and temperature sensor and connected to everything you want. This thing can be, for example, the station, and can be the thing that you're reading the messages coming down. But there are other models that I can also show you. So, for example, we have here, this one is a USB pen disk, also with a display. Later you can try it, it's also the material here. Plug it anywhere with a normal power bank, and it's running. This one costs 15 euros. Has a display, has a memory card, has Wi-Fi, has Bluetooth, has a software installed, has a huge storage. I mean, 32 gigabytes of memory here can store tens of millions of text messages. You just plug it over there, and then you have your own Nostr router now working over here to receive and to send messages if you want to. And then, of course, there is something that we are a bit more advanced. So we were talking about the walkie-talkies, and the walkie-talkies, you can think about them as your connection to the other side of the world, right? There is no Wi-Fi, but these things can connect to somewhere, like a local station that is 5 kilometers, 10 kilometers away with some area. But there are some inconvenience about this. I mean, this thing needs to be on, of course. You need to configure it. David knows how fun it is to configure these things, and they always work on the first one, right? On the first try. So you have to do a lot of trial and experiment, and it's not made to be running 24/7, which is kind of a problem, right? So we are also working on this topic, and I hope when we have the next session, we already have something like this, which is basically the chip inside of this walkie-talkie connected to something so small like this, another microcomputer for €7, and together for about 20 can be connected the whole day. Plug it to your USB port, put it on the window, and you can start receiving your data from here. This thing with Bluetooth connects to your phone on Geogram. That's the thing that we are building here. And the last but not the least is that these walkie-talkies, they are much more powerful than what we imagine. I mean, part of it, which was talking to satellites, and that's true. But what many people don't imagine is that the technology in their pockets, these cell phones that we have here today, they are already talking to satellites. I mean, every time that you use Google Maps to navigate to some point, you are receiving data from a satellite, right? You are receiving data that comes really far away, all the way into your car dashboard on the cell phone, and it's working. Look, it's already there, but the mentality needs to change slightly to think that we can also send data up. So it's not just receiving it down. Of course, many restrictions happen, many situations need to be taken care of, but physically it is possible. And you think about it, is it possible just with these more expensive devices? Is it possible with the mid-range devices? Is it possible with the cheaper devices? And the answer, it is possible even with the cheaper devices. We were doing the test, David, and with 1 watt, there was that accessory that we could send APRS up with 1 watt. 1 watt of power. This thing has 5 watts? 10. Who gives more? But anyways, we just need 1, right? This thing is quite powerful. With this, we can talk to satellites up in space. And you say, oh, legally, illegally. Well, it's a matter of, first of all, applying to have a radio license to some point so you can send data. And then, second of all, there is something that most people don't realize is that you don't need a radio license in most countries to receive information, receive messages. So you can today, even without a radio license, start getting the messages from a satellite. And you say, oh, which satellite can I use? Well, APRS, like David can tell you, it's a very old protocol from the 80s. The implementation is quite big. Many satellites implemented repeaters for APRS. I was telling already our friends here in the front about ISS, and ISS is a satellite, the International Space Station, that is flying every 90 minutes above our heads. And at every 90 minutes, this thing has a APRS repeater. And at this moment, when the thing is coming, the radio starts making the buzzing of all the digital messages falling. And when they don't talk, it's the time that you can actually send one of your SMSs up for free. So no subscriptions, no exotic hardware, no crazy things. You can do it today. Of course, today is a bit manual. We are working to automate it, but you can do it. And it works. So there is not so many people in Europe using this system. So when I'm testing, I can show it to you afterwards if you want to see it. It's always about the same 3 to 4 stations that are sending and receiving some messages. But just for your information, every time that I send it to a satellite up there in space, it has a reach of 1,700 kilometers of radius. So imagine that thing over here, but times 17. So basically I can talk from Portugal to Germany with coverage for free, which is much more than what I need, of course. And it's not the only satellite that does it. So here we are giving you several ways of contacting for the future. Using a normal phone, using a normal phone you can use Bluetooth, you can use radio, you can use the internet, and you can even use your shoes. It doesn't really matter, but the thing gets reused again. And that's basically what we are building here. Like I said, it's available for some people here for testing. So if you have interested in testing, come to me. It's still a bit rough on the edges, but it's working. In March, we should have the general availability. It is free, as in completely free. Open data is free. The hardware is not free. Of course, you need to pay for the hardware, but it's like 20 euros or 30 euros. It's affordable. And we also teach you how to assemble it yourself, or you can buy it here from the Embaixada for a symbolical price, or the GNPA, before I forget. Don't forget you get a discount on GNPA for all the selected articles. And for all of these things, it is available. So just stay in contact. Geogram.radio. And that's it, my friends.